I've started in Unity and that's what I've been using. I've been seeing a lot of commercial plugins to render point clouds, but I usually prefer open source solution to be able to work on that and try to learn and add your own sense on that.
That was Ruben Frosali, founder of TRIDOT and head of cinematic at JADU AR. Ruben has spent more than 20 years working across film, music, videos, real-time graphics, volumetric effects, shaders, and immersive storytelling. In this conversation, he breaks down how the background led him from point clouds to Gaussian splats. We look at how he generates Gaussian splatting.
There are so many ways to create as well, like generating them, situation like world labs. There is so much activity going on this field, and the was a really interesting one. Another really good advantage of solution like use it in this case to create for the 3D environments. It's how fast it is.
How he has integrated splats into Unity.
Basically, every time there is a light on screen in the scene in my Unity project, I have a script that look for all the lights in the scene, and it's basically saying, okay, I have a light here. Let me apply a light effect on top of that.
And then we move into something much more ambitious, interaction inside splat-based worlds without relying on traditional meshes or colliders.
There is no mesh here. And that's an interesting thing that it is the concept of this video that I was playing with. You're not doing colliders. You're trying to sense the world kind of in a way like a simulated LiDAR could be.
And despite his clear commitment to Unity, he points out a concrete danger looming ahead.
I'm kind of worried to see Unreal or Unity, losing some advantages on the open web. That's something that I've been noticing a lot of development happening there, but not as much in this world.
But before we get into it, I wanted to remind you that if you don't have the time to watch the full interview and want to learn from other founders and creatives at the intersection between XR and AI, you should definitely check out the XR AI Spotlight newsletter. By subscribing, you will get weekly interviews like this directly in your inbox and access to a list of tools and apps that allow you to experience Gaussian splatting in VR, on Quest, and Vision Pro. Just check the first link in the show description. And now it's time to roll the title and welcome Ruben under the spotlight. Ruben, it is a real pleasure to have you here again.
Thanks so much for inviting me again. I mean, you are basically like the northern star of everything happening in the Gaussian, AI, XR, everything is basically around you.
I'm trying my best, and I'm learning from people like you about what is actually happening every day. And I keep getting surprised. So I want to start asking you, right? Can we start maybe high level, break down your pipeline, and then we will kind of like look at each step more carefully, but just to give people a high level overview, when we see those videos on social media, on LinkedIn, on X, what are we seeing there?
As you know, I mean, I started working with volumetric content and point clouds, and from them I switched recently to the Gaussian Splat worlds. And for that pipeline, what I've been doing is, Gaussian Splat can come from different sources. I can capture them as with a regular pipeline similar to what it was before with point clouds. So, regular videogrammetry, photogrammetry, capturing things like that. And then I process them. I still keep using Metashape as the first step for the alignment. And then the next step of the real, processing of the splats is through, I'm not sure if I can pronounce it correctly, but it was Lichtfile Studio, I think.
Correct. Lichtfeld.
Lichtfeld Studio, yeah. That's the one that I've been using recently, and I've been really satisfied with that. And besides that, I mean, there are so many ways to create as well, like generating them with a situation like world labs or even SAM 3D generation of objects. So Gaussian Splat is becoming really something that can come from many sources, I feel like.
And then what happens after you have created the splats? Where do you start working, manipulate them, stitch them? Because there are several challenges. I Is that Blender?
It's not Blender. It's not Blender. I've been using Unity for a long time, from the time of point clouds, and that's what I still keep using. And it has the right balance between being able to work on the coding side to add new feature that maybe you find useful for the rendering, but also being creative enough and looking good enough to create output that can be shared and used. And also has a good connection with AR as well. So it's something that I've been playing more recently. But on Unity side, a very good base point where to start was the ARASP Gaussian splatting and rendering source on the repo. That was extremely useful to learn how to basically load the splats. And I basically merged my old point cloud shaders and system with this ARASP solution now, and together, plus a lot of optimization and changes that I've been doing over the years. So that's basically that. So I have support for multiple effects, multiple things that can happen. So
yeah, and so there is, imagine, a lot of custom that's going on. Later I'm gonna ask you also what can people do themselves, right? But before getting into pipeline, and you mentioned another angle. So I believe you started this manipulating point clouds using scenes that you have scanned yourself, right?
Yes.
Now you brought up instead the fact that there are different generative models that can let's say, add a third dimension to either images, equirectangular images, or in general, generate splats that don't come from reality. Can you give us a rundown? What are the tools that you have been using, and when you have leaned towards one other than the other?
It is an extremely, fascinating subject, this generation, because AI has an incredible potential, but at the same time, especially on the generative side, when we're talking about generation of images, I think every model that exists now can generate really good images. So we are basically on that side. But regarding creation of 3D worlds, 3D objects, and similar things, I think Gaussian splats have an incredible advantage in being much closer to this AI generation compared to meshes and similar solution. So with this type of solution, I've been popping out a lot. And one that I'm really, really fascinated is world labs that allow you basically to generate 3D worlds, starting from an image or a text prompt. And it's not just about the creation of something, like I was saying, like an image that looks nice and that's all. Those are real worlds. So they feel coherent. It's something that is completely different from an image, and it has so much potential. I'm really, really fascinated by this.
Yeah. And I think this is something that people do not understand often, in a sense, like coherence has different layers. There is a stylistic coherence. That's one layer to it. Then there is also the geometric coherence. Exactly. So it doesn't add completely random things to the space, right?
It does not. Yeah.
And so that is an element. On the other hand, there are also other models that maybe don't have so much imagination as Marble has, like, for example, Sharp or Sem3D. What is your take about those models to generate splats, but in kind of like a different approach?
It is extremely fascinating because, as I said, there are coming you're coming out very quickly, and there is so much activity going on this field. And the Sharp model by Apple was a really, really interesting one, because on one side, it basically converts a regular photo, into a Gaussian splat. It is view dependent, so it's not creating like the sides like maybe World Labs does, but it is extremely realistic in the way the model works, and it is extremely easy also to install and to work with that and to create pipelines using that system. So yes, it has been a really, really interesting thing also to see how it works and to try to figure out creative uses for that.
So can you give us an example about this pipeline, maybe that you have experimented with? You mentioned Sharp, maybe.
For sure. One interesting thing that, because this is some type of research I've been doing more at JADU AR, where I was before working more on the cinematic aspect. Now I'm more on the research and development side. But what I was, I'm going to share my screen a little bit. But an interesting approach was trying to figure out solution to integrate Gaussian Splat in new pipelines, and playing with different tools we are available now. One that is really interesting was Sharp, with the ability, to capture, to create a Gaussian Splat from a single image. And how can this be extended? In many ways. I found out that there are solutions, for example, starting from an equirectangular image, similar to what I have here, is like a 360 image warped and in a single image. So I was thinking at the time, okay, what if I take this equirectangular image and with a cube map approach, I just extract like 6 sides, so front, left, right, and right, and I process that with Sharp. And then, with Sharp is extremely interesting also because it has parameters of, field of view when it processes the image. So you end up with scenes that have an understanding of the, dimension of the location as well. So you can use those data. And if you process like a singular image like this, divide in 6 blocks, process each one, and stitch them together in Python, you end up with an environment that is basically a 3D environment projected on 6 sides and all connected together. And it's not World Labs because it doesn't have like a,
Exactly. So from your personal perspective, right? What are you? So on one side, you have control. That's one thing you have, right? Because you can write your own script, and of course, it's something that can run on your machine, and that has absolutely value. From the other side, you lose a bit what is, let's say, the full imaginations thing, right? Because these scenes break very easily as soon as you move out of the very center. What's your take? Like, do you see one more suitable for one use case other than another? Maybe you can pause the video and we can kind of like.
Sure.
What do you think?
You're right. And, so solutions like World Labs, for example, they create this full 3D environment that doesn't break. So if you are inside those worlds, you can walk around. And I did a few tests blending reality with these worlds. The Sharp aspect is a bit different because it's a projection. So in those cases, I've been exploring also ways to create like a gap fill effect to at least get them slightly more visually pleasing, looking at the side of that. So that's another thing that I've been working on. But I think, another really good advantage of solution like Sharp, used in this case to create for the 3D environments, it's how fast it is. Because one image is basically like a 3-4 seconds of processing time, and creating an environment like this is almost like instantaneous. It's like 30 seconds. So even if it's not perfect, it has that advantage that it's basically ready.
And where does it matter? I mean, in a sense, like I understand speed is crucial, but does speed matters when it's about a real life use case? Because maybe you want to do something that is part of an experience, and so you want the user to generate that, or it's important for you as a creative so that you can iterate faster, or maybe there are other reasons why this speed is so crucial.
The speed, I feel like it's very crucial and important, especially for the work that we've been doing at JADU as well, because we want something that feels real time. And that's one thing with other Splat solutions that are not real. They don't feel real time. So you have higher quality results, but you don't have like an exact thing. There is, when you can capture something and have the same object in 3D existing near you, blending with reality in 10, 15 seconds, it gets to the threshold that it's almost real time. When you have to wait several minutes, it's a different type of process. Both are very valid, I feel like, but different user cases.
Exactly. So one serves more the, let's say, deployment, right? And it's like, okay, this is something that's going to be part of the app, part of the experience. The other one is more a part of a creative workflow, and maybe the place is used as a world of a game. Then it can be, it doesn't matter the time. It can even take a few minutes if I can get better quality at that point. Maybe can you give us now, because people have been seeing this kind of like crazy effect going on. So going maybe towards the beginning, let's say that you have generated a splat in different ways, as an environment, in Marble or Sharp. What happens then? How do you get to those effects, dissolution, for which you are famous, by the way?
These explosions. I always explode everything. These are coming from my background, working with point clouds. And that's where I started. It's a process that I started at the time when I was rendering the first point clouds, that I only had like the XYZ of points and their colors and space. And that was what was available at the time. And I started playing with that with shaders, with Unity shaders, using math formulas to create effects, to create variation of movement, of colors. And an interesting thing that happened was, when Nerf came out, those were really fascinating because they're very close to Sharp, to Splats now, but they were so hard to work with. So I spent a lot of time trying to make effects for that type of solution, but failing miserably. And when Splat came up, that was a really, really interesting thing, because Splats are very much closer to the point clouds that I was working with before, because they are basically, instead of being like points, they are these floaty, blobby, transparent objects, but they have a position in space. So once you have that, and they have a color and they have an opacity, once you have that, you can basically apply the same logic in the shaders of effect to this type of solution. They're slightly different. They look slightly different. Some effects works better than other on Splat and point clouds. But yes, it's basically.
And so these are maybe also to please people's thirst. You mentioned that they started with the RSP Unity plugin.
Yes.
And is there anything else that people can kind of like get their hands on, besides, of course, that is strictly your custom built shaders? But what else would you suggest for people that want to maybe start creating these effects and animation or dissolution or anything? At least when we're talking about this animation, we'll talk about lighting shortly, because I've seen it also in the video. But when it comes to animating something like this, what do you think are the options available to people?
So one thing is that in Unity, I've started in Unity and that's what I've been using. I've been seeing a lot of developments happening other places, a lot of solutions that are much easier to work with happening in other places. I've seen solution in Unity as well, plugins. I'm not sure about the name, but I've seen commercial plugins to render point clouds. But I usually prefer open source solution to be able to work on that and try to learn and add your own sense on that. But for example, on the web, it's a much easier step with 3GS and Spark. Those are incredible SDK platform that I think if I was starting now, instead of trying to maybe to work in Unity, I will probably play with that before.
So this brings another question, right? Because we mentioned of course, the core goal being the final use case of what you create. Do you feel that when you start creating this in Unity, either with something like Spark.js that has this very advanced, almost pre-scripted kind of like dissolution effect, and do you restrict the use cases, or you are directing more into one type of use other than another if you pick these two branches?
Yes, it really depends, because even there I've seen a lot of really cool experiments coming from on the web, especially on Three.js and all that is connected to that. And Spark and Gaussian Splat are relatively new, so I feel like it's a world exploding soon. Even Spark.js, I've seen that the version 2 came out very recently. But if we think about Splat in general, we are talking about technology that came out a few years ago. It's not something that, it has that past. So I feel like we are probably going to see a lot of development happening on the web. For sure, if we want to play with AR, especially, or other type of experiences, I think solution like Unity or there are other ways, other interesting use cases. Like I do a lot of video production as well with my Unity plugins and work. So that's another case where with Unity you can control how the quality and the rendering side. It's much easier to produce something like this. But on the website, if you want to push something on the web and let people see what you're creating, I feel like it's an amazing solution. And, another interesting thing that I've noticed that I'm slightly worried about is that I started working, with computers and 3D graphics, not just 3D, but interactive things back in the day with Flash action script. That's how I started. And I remember very, very well when Apple, but all the open solution kind of killed Flash in a way, right? So they disappeared.
And so you mean what happened is Spark disappear? That's the kind of worry you have, or
I'm kind of worried to see like solution like Unreal or Unity, this closed solution, losing some advantages on the open web, and solution like Three.js, Spark. That's something that I've been noticing a lot of development happening there, but not as much in this world.
And this is also in a way a frustration, because people, especially in the 3D world, gets very excited about the photorealism and the opportunities that Gaussian splatting has to offer. They maybe come over and ask a question. Hey, Gabriele, we want to bring this in VR, in this interactive environment. Are you using Unity? Yes, we are. Well, I'm sorry. I just don't feel that right now, at least to my knowledge, there is something capable, or we are at the stage where that's possible. And my next question is, have you tried Play Canvas? Have you tried Spark.js? Because that's where I feel like more experimentation with, for example, the LOD is happening. There is this new RAD format, there is the SOG and more. And I think that's where they are moving a bit the needle. But while you play the video, I want to ask another questions, because the other concern of people, even they come to me, is like, hey, look like crap. What can we do with lighting? Gaussian splatting, that's been one of the challenges. It's not a mesh-based system. So how do you tackle that once you have got stuff to explode? How do you get it to have more control, for example, on lighting effects like the one we see?
It's interesting how splats work, especially in Unity, and considering that as I said, is something that was created just a few years ago. So of course, mesh polygons, they have a long history in computer graphics, and we know everything about how to render those. The thing is that with meshes and polygons, you end up with objects that are very close to the computer world, to the CPU world, but not to reality. Gaussian Splat have that advantage, but at the same time, there isn't as much research yet on that, but still things are moving very, very quickly. On the Unity side, for example, rendering splats is pretty weird how it works, because it's not like they are objects like meshes on screen. It's rendered on some sort, let's imagine like a texture that is outside the screen and then pushed on this layer. So it's not fully integrated with other 3D objects. So different splats, you need to do a lot of works to make it seamless, and it still is not as seamless as other 3D objects. Even stuff like lighting can be a challenging, although I'm sure now everybody has mostly solved this issue, but it used to be very difficult before because as you said, there are no normals, so you don't know exactly where things are placed, or at least there are way to figure things out, but not as easily as meshes or even point clouds. So when I had the support for lighting, basically every time there is a light on screen in the scene in my Unity project, I have a script that look for all the scene, all the lights in the scene, is taking the coordinates of that, the colors, the intensity, is moving that to the shader that is rendering the splats, and it's basically saying, okay, I have a light here. Let me apply a light effect on top of that. And so this is, I already had this working before, because when I was working more with point clouds, that is actually how it worked there. I wasn't using Unity to directly had lights there, but you have to do these steps. You have to consider that you are manually interacting with the splat itself.
So may I say, and Ruben, correct me if I'm wrong, right? This is a level of colorization of the splats, other than have a way to casting shadows and something like this. Am I correct?
It's more of a way of coloring, not in a 2D sense, not on a screen level, but on the splats itself. It's a way. But in the end, light is this. Lights is a way to do this. And even, if you think about computer graphics, even shadows is another step, is another pass over this lighting. So while you can think about, on a mesh, you have the light and the shadow being cast over, it's still different passes on the rendering side. So it's possible to do shadows on Splats. I also did this, a few experiments, and I have a few solutions that I shared about. There are ways, but it's something that everybody's trying to figure out, I feel like. There are no solution that you can follow. You just test that you can do to figure out the best solution, the most optimized solution to do that. And that's why also I feel like, splats are really fascinating, because the potential and how new they are. So that's...
So then you have mentioned several times that you are working on something specific for JADU, and maybe actually, I think you're right. Let's maybe go through the whole video. You can maybe walk us through since what's happening, and then we can talk a little bit about what you're actually doing at JADU.
Yeah, so these are just effects that I've been building and testing on this 3D environment. Testing lights, testing the sharp process of processing 3D.
Camera depth of field.
Yes, as well, the depth of field. This depth of field was really interesting because instead of using the actual screen depth, I'm actually changing the size of the splat element to simulate the effect of the depth of field. So it's a bit different type of process. Just test. I think I saw this from, if I'm not mistaken, it was something that I read in the code from the first Spark, but I may be wrong. I'm not sure if it's coming from that, but it was really, really useful to figure this thing out. And your question about what we are doing with and this is another effect that I had before, like some type of water effect moving through the splat. So at JADU, what I've been experimenting more recently is there are a few different things, but mostly it's about taking splats and making them easier to be integrated with reality. And that means mostly, a lot of optimization happening there to try to make them render better. on the small devices like, a smartphone. We are mostly focused on the smartphones, and also how to blend them well with reality.
Yep. And so you were saying that you are doing a lot of optimization to make these splats running on a mobile device. How are you doing this optimization? What are we talking about? Reducing the number of splats or doing some compression? How's that work?
A lot of steps. You have to think about splat both in terms of size and in terms of how many splats you can render on screen. And this is something that everybody's working towards solving this. Very well also on headsets as well. There is so much things coming through, much research as well. So one interesting thing was about, reducing the number of splats, trying to figure out things how, just to render those splats that are more important in shaping elements on the screen, as well as, not just about the speed itself, the performance, but also in how they blend with the reality. Because if you think about Splat, it's really interesting. I think I've seen example like Gracia AI and all the 4DGS that is coming through. It's just a different thing compared to meshes. They blend very well with the reality.
So from a purely technical side, right? Because people are always obsessed, and I think they have a good point. So what are we talking about when we are talking about optimization? Are you still using PLY? Are you using different file format like an SOG or a compressed PLY? And maybe around what kind of benchmark do you end up in terms of file size and number of splats?
Even there, it depends a lot about your users. And there is also the thing about the file size itself that is useful to think about, but also in terms of the rendering. That's another thing that is important. On the file size, for sure, PLY are the largest one. The compressed are fine, but they can take a lot of space. SPZ or other solutions are much more working well on devices because they're compressing. But the real bottleneck is often how to render those point clouds. So, those Gaussian splats. So, level of detail changing, being smart in how you render these elements, try to figure out how to skip some steps in the process. So I think, and there are no perfect solutions. Every device has its own things to work with.
So, and this level of optimization is something that right now you are doing, or you try to fine tune in Unity. Am I correct?
Yes, we are. Yes, we are based on that in Unity.
Clear. And I want to actually share some of these examples that I think are fascinating because it shows a bit of the application of something like this. So here we have what we could define as a robot, technically. I mean, we could define it however we want, but let's say we have this robot basically entering in a scene, and what we see here, it's navigating a splat, but also it's generating what is like if there is a camera attached to his face, right? That is looking at the environment, and we're seeing that with a, let's say, fictional environment, but this could actually be another case of real one, right? There is also a different smart thing as the camera that follow the spider kind of moves to make it as if we want this to be a controllable robot in an environment, right? So there is a lot of stuff going on. There is also the mesh recognition that is happening, right? Because it's literally climbing a bit everywhere. So
there is no mesh. There is no mesh here. And that's an interesting thing that it is the concept of this video that I was playing with. I was thinking of, because these worlds are coming from World Labs. So they are fully created worlds. And it's pretty difficult to get this type of test scene to try to figure out how you can interact with Splats directly with other type of solutions. So World Labs helps a lot with this. One interesting thing that I found out about working with Splat was how do you target Splat if you don't have a collider, a mesh to give you where are the 3D objects, because Splats are basically these objects that are floating, these little bubbles floating around. So I started testing some idea of raycasting over the splat itself, the element splat itself. So pointing and understanding when a line touches a splat. It's not easy, but it is a process that is possible, and looking mostly about, of density or opacity of the splats and different steps to figure out if this is a solid element or not. So that was like the first thing that I found out a while ago, and it was really interesting in pointing to different splats to apply effects on this hit point. So I took this robot walking, and I thought, okay, let's try this approach. I'm going to put like this raycasting happening on each leg, and let's try to make it work in a world created just by Gaussian Splat, without any meshes, without any colliders and anything. And it was tricky to find a good balance of understanding, what are the splats that are really solid places, and what are those fuzzy elements that are very hard to define. But in the end, it worked out. And so it was really surprising to see how you can work. And this is another thing that is extremely fascinating about World Labs, world generated as Gaussian Splat, because they most represent reality. They really are closer to represent reality than any meshes could. So you have your robot, you take it there, you're not doing colliders, raycasting, but you're trying to sense the world kind of in a way like a simulated LiDAR could be. So you're really raycasting things and testing how things look like. And I've been trying to make other experiments there to have this way of sensing reality through that.
Can you give us a bit of like end goal scenario? Faint, right? Maybe there is this experimentation. Of course, the target moves based on where the technology is going and what's possible. But where do you envision something like this taking place when seems like you want kind of like to create this interactive gaming experience? I'm not sure. So can you maybe give us an idea?
You know what? I'm not really sure as well, because there was on one side, I've been trying to figure out with JADU all these things about how to integrate splats into AR and the real world and interactivity and the formation of splat. A lot of things to make this more real and more integrated into reality. But this is also something that I've been exploring to try to figure out what is the potential of splats, especially these world models of splats, because it is extremely fascinating. Because if you can generate worlds, like example like this or other, with using AI, you can generate this coherent world that you can move into and explore. You can use those also to train things, to train AI, to train robots, vision, whatever it is. So my mind started thinking when I was thinking, okay, if you can do that once and it's all connected to procedural generation and testing, this can be automated. And in that case, you can just run it and create and run and do tests. So I'm really, really interested now in how you can use these worlds to create better ways to interact with them, but not, I think, in an academic level now, in a way, because I'm not seeing an application personally for me, but I'm really fascinated in, I would say robotics. That's something that it's really, really interesting, and just playing with these things and trying to figure out how to use them.
So when we think about, I think that there is a wish or the desire, I think at least from all the XR community, to start stepping into this in some way, right? It could be, for example, on a phone even, right? Just to start with, but then ultimately in a VR headset. Do you think that what's stopping that is that, for example, let's say the development environment like Unity, or you mentioned Spark? Is that the device capability? Is that the specific use case? What do you think is kind of like needed in order to be able to start in getting this interaction outside of a screen, outside of a monitor, but more like into the real world on a phone or on a VR headset?
It's there are multiple things to solve because of how new everything is. And as I said, if you think about regular VR experiences or anything that exists in computer graphics, we are all based in the same meshes, polygons, rigging that we had before. Everything is optimized for that. So playing with Splats now, using Splats now, it is a different type of process that for sure will require a lot of work in terms of optimization and making it work as seamless as possible, not just for performance, but also, for how they blend together. So I think it's going to happen. And, you have already seen like 4D Gaussian Splat moving into the Vision Pro or other solutions, world that you can step slightly into. But it's going to happen. But if you think about like 1 year ago, it was pretty different. So for me, it's just a question of time and the why. I mean, the worlds of World Lab, for example, those are incredible places. But if you can step in any of them, if they're just pretty places, what's the point? So there's for sure there is a meaning to be found there.
Absolutely. And you have mentioned several times animated splats. And I was wondering, what's your take on them? Maybe also from a production side, because I think also when we think about animated splat, we always think about the expensive camera rig, and maybe an actor or a performer in the middle of it. I think that that's not the only way we should think about it, especially when we have models like Sharp who could technically make a 3D environment for every frame of a video and turn that. Or we have this synthetic camera rig, right? So in a sense, there are some tools made, for example, by Olli Huttunen that creates in Blender this camera rig around an object and can be animated, a scene that can be animated and then reconstructed as a splat. So what is your take about bringing these animated splats and producing them, and maybe in general also from a creative perspective, taking advantage of the features that point clouds splats have to offer?
I've been working with volumetric content for a long time, both in terms of point clouds and also like volumetric capture. That's something that I've been working in many music videos and content. And in the big green screen area with a lot of cameras capturing everything in 3D that used to be meshes before. Actually, I've been seeing a lot of 4D Gaussian Splats happening, studios working on them and sharing their work with me. And I'm seeing higher quality than, or at least not, I wouldn't say higher quality than mesh capture like 4D views or similar solution for capturing in studio, but blending better with the environment, using less cameras, because a lot of for DJS being done can be done now with a bunch of iPhones connected together in a rig, and this is way cheaper than it used to be before with the full studio. So in that sense, it's not as expensive and not as complex. At the same time, things like Sharp, for example, as you said, you can create something like an animation, take a video and convert that to a 3D animated splat. But in that case, though, it's still kind of like a flip book effect. And it's very heavy in terms of file size and things. I think we're going to see some changes there in the future where we are not doing anymore this flip book approach, but we are actually kind of rigging elements in place. I've seen example of faces that can change, and they have a few different approaches to create this animation that are really good. That is a mix between training and deformation applied to that. So it's probably becoming, yes, this dynamic splat playback is probably something that will require a bit of work.
Yeah, no, I know also because I've been in contact, for example, with the team at Gracia, and they were explaining that the approach that they take to prevent that, let's say, flipbook approach and consequently that jitteriness, and instead to allow the temporal stability, is that they use what they store as information is how the splats change over time as an equation, instead of having like 1 PLY per frame. And so this makes it possible to create these flowy animations that are also compressed, because there is not the storage of each PLY, but instead like this function of how the properties of each splats change over time. And that's I think one of the reasons they were able also to create these streaming splats. I don't know if you had the chance to try them out.
Yes.
And that was like pretty crazy, because when you can click play and see a splat, like a YouTube video, I was like, okay, this is actually pretty insane.
They are amazing. I talked with them a few months ago, and I really love what they are doing. But they're not just the only one. I know other people working on these solutions, and as you said, there are approaches. It is tricky to think about how to animate splats. There are a lot of new invention to be made, new exploration to be made. So it's really fascinating to see this happen. And there is no rigging. You cannot take a splat and keep it like that.
But that is why I think that there is potential.
Oh yeah.
To move towards the synthetic way, because then when everything is possible with meshes. Right, so you can animate and you can use those. You can also add the particles that then are gonna look super realistic when those smokes or flames are then turned and captured into this synthetic environment in Blender or Unreal or whatever it is. But then it's brought into a way that can be distributed as ultra photorealistic, because allows the splat, something that would be impossible to achieve because a smoke, a flame, or maybe super high polygon, super high quality would be too heavy. But instead, for that deployment, for that distribution, you use instead the splats. Let's see.
Exactly.
Maybe in 1 year from now, we're going to talk again and we're going to see like, okay, so Gabriele, how much of a bullshit was it what you said 1 year ago? And we'll see. I'm curious.
We'll see. But you're completely right about that. And it is a fascinating process to see happen real time. So, yeah, exactly.
Absolutely. So, Ruben, maybe just to close up, what can we expect from you in the upcoming, let's say, this year? We're going to see something that I can actually put my hands on, because that's my question. I needed to ask you live in front of people, because then if you're going to make a promise, you got to keep it.
Yes, I think so. Mostly for the work we have been doing at JADU, and we've been working on a new product that we're going to introduce slowly. We don't really want to be, like a big release. We are trying to create something that is exciting and would kind of redefine what means like this working in the like spatial intelligence, I would say, plus this capture. And we're going to have a first event next month in Los Angeles. So I think we will show more of that in that point, and then more coming later. But I'm really fascinated I'm really, excited that we will be able to share some way to capture and access these splats and other objects and in your everyday life without any headphones or something like that.
Amazing. So, Ruben, I'm going to be the one on top of the waiting list. I don't know where do I need to sign up, but thank you very much, Ruben. It was a real pleasure. Looking forward for that and to more of your experiments. And of course, for everybody here, Ruben has also a Patreon that you will find down in the episode description. You can check out on top, of course, of his social channel being Ruben Fro on X and on LinkedIn. Ruben, it was a real pleasure.
Thank you so much, Gabriele. It was a pleasure for me as well.
Thank you very much for listening in. If you like the show, remember to leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube.
It really helps me keep doing this and shine the spotlights on the greatest founders and makers, pushing the boundaries of XR and AI. Also, make sure to check out the show page xraispotlight.com, where you can find more conversation like this one. Till next time.